Okay, for these questions, we have to label all the forces on the rocket. Okay, imagine that this is a rocket and there is going to be a downward force, which is the weight, and it can be calculated by W is equal to mg, and this is equal to 3.2 times 10 to the power of 6 times 10. This will give us 3.2 times 10 to the power of 7 Newton. Okay, next, there is an upward thrust that is provided by the engine, which is 3.4 times 10 to the power of 7 Newton. So we label in as well. And the resultant force of the rocket, it can be found by taking 3.4 times 10 to the power of 7 minus of 3.2 times 10 to the power of 7. This will give us 0.2 times 10 to the power of 7 Newton, and it can also be expressed as 2 times 10 to the power of 6 Newton. Okay, since we have the resultant force, we can find the resultant acceleration. Using the formula, resultant force is equal to ma. Our acceleration is actually equal to the resultant force divided by the mass, which is 2 times 10 to the power of 6 divided by 3.2 times 10 to the power of 6. This is going to give us 0.625, and if we were to round it off, it becomes 0.63 meter per second square, and that will give us the answer B. This is a question on principle of moment. As we can see, there is 3 units of weight on the left side, and it is 3 units of distance from the pivot. So with this, we can calculate the anti-clockwise moment, which is equal to the force multiplied by the distance. And the force in this case is represented by 3 units of weight multiplied by the distance, which is 1 unit, 2 unit, 3 unit of length. So total we have 9 units of anti-clockwise moments. And on the right side, there's 2 units of weight, and this will contribute to a clockwise moment, which is equal to force times distance. Force is 2 units of weight multiplied by a distance, which is 1, 2, 3, 4, 4 units of distance to the pivot. So total clockwise moments, it will be 8 units. Okay, in order to balance this seesaw, we need the anti-clockwise moments to be equal to the clockwise moments. So now we can see that we are short of 1 unit of clockwise moment, and additional clockwise moment can only be achieved by placing a weight on the right side. So definitely option A is out, and it has to be placed on the position B, because the weight is a single unit. So the clockwise moment is equal to a force of 1 unit, and we have to multiply by a distance of also 1 unit in order to get 1 unit of clockwise moment. And with this, we can balance the seesaw. So the answer is B. Okay, this laminar is pivoted at point P, and the weight is 2 Newton, and the center of gravity is at C. So the weight, it will act downwards directly at C, and this is 2 Newton. And since it is pivoted at P, this downward weight is going to create a clockwise moment. So to find the clockwise moment, we have to first find the perpendicular distance. So now we extend the weight to get the line of action of the force, and then from a pivot we draw a line that is right angle to the line of action of the force. It's at right angle here. So we can see that the perpendicular distance is actually this distance, which is equivalent to QC. And since QC is 0.3 meter, we can calculate the moment as moment is equal to force times distance, which is equal to 2 times 0.3. We will get 0.6 Newton meter clockwise. Okay, so answer is A. Okay, for this question, right, when a metal is heated, it will cause the volume to increase, and if the volume increases, the surface area will also increase. So option D and option C will be wrong. And as we know that the density is equal to the mass over volume, if let's say the volume were to increase, it will lead to a decrease in the density. So option A is also wrong. So the answer must be option B, which is mass. And the reason is because mass is the amount of matter or particles in a body. So even when the matter is heated, the amount of particles or matter remains the same. Okay, for this question, right, we need to find the volume of the metal block, which has a hole in the middle. So the volume can be found by this, which is the volume of the entire metal block, which is 5 times 4 times 10, minus of the volume of the hole, which is 3 times 2 times 10. That will give us 200 minus of 60, which is going to give us 140 cubic centimeter. And to find the mass, we just need to take the density multiplied by the volume, which is 10 times 140. This will give us 1400 gram. So the answer should be C.